just a moment. So it says we used repeated sampling. Abdullah, you can put that away. Please take out your workbook. Phone should be away too. I know, this darn class gets in the way. We use repeated sampling to try to estimate what the actual average is, okay, of large populations. Yesterday we talked about 100 rectangles. But what if it was 1,000 rectangles? What if it was a rectangle for every American? Those are huge numbers, okay? So if you get data like this, shown on this page right here, the Promethean board, what would we expect the average number of times to land on the pink to be in these situations? If I spin these spinners 1,000 times. So these are two spinners and they have a pink section area. Okay. What percent of the first circle is pink? Let's try that first. What percent of the first circle is pink? 60%. Do you guys agree with that? How did you get that for those that are not quite as fast on their feet? How do you know that 60%? Yes.
Oh, because 3 out of the 5 are filled and there's out of 100.
Yeah, there are 5 sections total, right? That would be the number out of 5. And 3 of them are pink. And if you change that into a percent, that means out of 100. And so you multiply by 20 over 20, and that gets you 60 out of 100, which is 60%. Okay? What is the percentage of pink for the second circle? 50%. That one's a lot easier, right? So that's 1/2, which is 50%. You do not have this in your book, so don't be looking for this in your book. So the question is, what would we expect the average number of times that we would land on pink to be in these situations if we spun these spinners 1,000 times? Okay? 1,000 times. What percentage of the time do you think we would land on pink? What? What percentage of the time do you think we would land on pink if we did this 1,000 times? I'm sorry? On the left side. So we're looking at this graph first. What would you expect the average number of times to land on pink to be? Okay. The average number of times. Okay, 600 out of 1,000, which is what? 60%. So you're saying if we did this 1,000 times, 60% of the time it would come up in the pink. Okay? Do you guys agree with that? Yes? No? Yeah. I mean, that's why these are kind of probabilities, but that's why we do this. What about for the second one? If we spun that 1,000 times, how much of the time would you think that it would come up in the pink? Yeah. Okay, so 500 times out of 1,000, which is going to, again, be 50%, right? Is it going to come out pink all the time? No. But if you do things often enough, you should get close to what the actual shaded part is. So that's the 60% and the 50%, okay? All right, let's go to this next slide. If, that's a big if I spin these 1,000 times and I get 45%, that it came up pink. Which spinner was I probably using? Because sometimes you're not going to get the exact color or the exact percentage that is given to you. Okay? You might get, like it says, 45% pink. Which spinner do you think you were probably using? The first one or the second one? Why? Remember, this one is 60%, right? And this is 50%. And you think you would get pink 45%? If you got pink 45% of the time, you think it's the first one. Why? Does anybody think it otherwise? Aiden, what do you think?
The second one.
Why?
For 45, the pink's majority of the first one. How's it?
Okay. That kind of makes sense. Anybody else have something they want to share? Stephanie sharing gum. Stephanie, what do you think? If we got 45% after spinning both of these 1,000 times, which spinner do you think we're probably using?
So how much percent?
45. I guess for me, I think what is 45% closer to? Spinner 1 or spinner 2? 2, yeah. So I would think that we were probably using spinner 2 if we got 45%. Do you think it's possible to actually get 45% for either of them? Yeah? Both? One? Okay. Well, let's take a look. So take a look at this data, and this is on page 44. Okay? I believe it's on page 44. Let me see. Can I see it? Yeah, it is. So we had 150 people spin each spinner 100 times and showed their data just like we did kind of yesterday in CODAP, but we didn't get to do this. This says population proportion 0.5. Okay? This is a sample size of 100. All right? So the population proportion is 0.5. Here the population proportion is 0.6. So this is my 50% and this is my 60%, right? Sample size of 100. What do you notice? And this is my sample. Okay, this is just the sample. Which graph has 3/5 of the section in pink? Which graph has 3/5 of the section in pink? And how can you tell? Yeah, graph 2. How can you tell? Yes, so if you look here, 3/5 of the section is in pink, okay? 3/5 is 0.6 or 60%, and as you look here, so the actual amount of 60%, that one is kind of low, but take a look right next to it. We have, this is 0.61, 0.62 right here. We have 0.59. So all of these are close or around 0.6, which is 3/5, right? So the one that had half pink, if you look They're all centered around 0.5. Now 0.5 is a little bit lower. The maximum amount that they got was at 0.49, but they're all really close here. So that's close to 0.5, which is about half, right? Okay. So if you look at this, if we would spin it 100 times with both spinners, which one is more likely to receive a result of 45%? Looking at those graphs, and the graphs are also in your book, which one is closer to receiving a result of 45%? Graph 1 or graph 2? Why? Yeah, there's a whole lot more here. Okay? See this? Here's 45%, and you've got several in that height. 45% over here. Okay? There's none. None there at all. All right? So here's the 45%. Here's the 45%. And so the 45% is closer to the one that was showing 1/2. All right? Any questions about that? And how to read these graphs? These are called dot plots. Dot plots. Okay? All right. So, take a look at page 46. If we polled 100 people here at Pike, well, maybe not here at Pike. If we polled 100 people and we asked on a scale of 1 to 50, with 50 being a high, how satisfied are you with Pike High School? And we repeat the experiment several times. Which of these graphs would best match if the actual population response is about 30? So if we polled 100 people on a scale of 1 to 50, how satisfied are you with Pike High School? Which of these graphs would best match the actual population response of about 30? Don't say it out loud. Sure, I want you to use this. It's got to be a whole lot easier. That's up to you. So we're on page 46. Everybody got an answer? All right, so we have them. Let me take a look here. Okay, how many say everybody picked their graph? Ron, have you picked your graph? Take a look, pick your graph. Which one shows the actual population response is about 30? Got your choice of A, B, C, or D. All right, how many say graph A? Raise your hands. Okay, how about graph B? Graph C? You say C? And graph D. Wow. Arturo, why did you pick C?
I read the numbers, 30.
Yeah, 30. So let's see if I can zoom in here. Is this zooming in? Why isn't it zooming in? Oh, that's so irritating. Yeah, why did most of you pick D? Quick, why did you pick D?
Because most of them end at 30, but some still don't.
Yeah, look at where the 30s are and where the data is, okay? So if it says the actual population response was about 30, I mean that you're looking for where the majority selected 30. So that is graph D. Arturo made a mistake, said he couldn't read the numbers. Is it likely that the actual population would give Pike High School a 50? No. Why not? Oh, come on. Look at the graphs. Is it likely they would give them a perfect score of 50? No. No. And we're talking about the majority of the people. There might be a few that would give them 50, but the majority of your population, no. I mean, this only goes up to what number here? 40 in all of them. Okay, so that is not going to be very likely to get the majority to select a 50. Any questions on that? All right, now open up to page 48. Task number 35. If you won $10 million, what would you do? If you won $10 million, what would you do? And there is a full article here if you're interested in that. It says a recent Gallup poll article found that almost 2/3 of Americans would continue to work even if they had won $10 million in a lottery. The poll reported that some number of Americans would continue to work. Okay, so we're not giving you the actual amount there. Letter A. Do these results surprise you? If the prize monies were to increase, what do you think might happen to the survey results?
It gives us,
Oh, does it give you the amount?
it gives you the percent instead of the question marks.
Oh, 59%? Bummer. Okay. So do these results surprise you? Are you surprised that 2/3, 59% would continue to work? Really? Why? Can't keep going like this. Does that surprise you? No? Okay. So write down a few things here. Letter B, do you think the Gallup organization called every household in America? If not, how did they arrive at that estimate? Letter C, if Gallup took another sample of the same size, do you think they would find the exact same results? The article reports a margin of error of plus or minus 3 points. What do you think that means? All right, so take 5 to 7 minutes, answer these questions, and then we're going to talk about them, okay? 5 to 10 minutes, answer these questions, and see what you think. Andrew, do you have your pencil? You need a pencil? Okay. To be a good discussion. So, do these results surprise you that 59% or almost 2/3 of Americans would continue to work? A couple of you said no, that would not surprise you. Anybody surprised? Why are you guys not surprised? I mean, $10 million. Andrew, that's a lot of money. It's not? Not to what? Not in this economy? $10 million? Why else? I mean, Jesse says no, it's not enough money. What if you put it in a high yield savings or invested? If you put it in a Roth IRA, a Roth IRA, there's different IRAs. It's a thing that you can put money in. You have a Roth IRA, which the tax and stuff comes out before, so once you actually take it out, you don't have to pay taxes on it. And then there's a traditional IRA where you have to pay taxes on it once the money comes out. Yes? Yeah? Well, I don't know personally when you win the lottery, but yes, I've heard. A lot of money what? Mm-hmm. Yeah. You don't actually get that much. Yeah, that's absolutely true. I mean, usually a third of it goes to taxes. So if we're talking 10 million, maybe you're down to six and a half, something like that. But that's still a lot of good money. Okay. What if the prize monies were to increase? What do you think might happen to the survey results? Do you think they would change or affect it? Yeah. I mean, if it was $20 million, 20 million would make a difference. How about 12 million? That's maybe not quite enough, huh? Okay. So, letter B, do you think the Gallup organization called every household in America? No. How do we know this? How do we know this? Can we even reach every household in America if we wanted to? No. Some people don't have phones. Some people don't have numbers that are known to everybody. So, how did they arrive at this estimate? What did they use? They used a sample, okay? And hopefully it was a good sample. What's the best kind of sampling technique we can use? Simple random sampling, okay? Simple random sampling. All right. Letter C, if Gallup took another sample of the same size, do you think they would find the exact same results? Would they find the exact same results? No, probably not. I mean, would it be similar? Yes, hopefully. If it's a good sample and a good sampling technique, it will not be exact. Okay? And letter D, the article reports a margin of error of plus or minus 3 points. What do you think that means? So it said 59% in your book. Come on. 59%. A margin of error of plus or minus 3 points. What do you think that means? Margin of error. Karan, what do you think that means? No idea. Never heard of margin of error? Error. You've heard of error. Okay. Yeah. That 59% might be wrong by how much? Okay, by 3 points. So that means we could go down 3, which would take it to a 56%, or we could go up 3 to 62%. That's what it means. All right. What is this error? Why would they account for that? I mean, and look, that's a total of 6 different percentage points, right? From the low to the high. Why do you think we have these margin of errors? Educated guess. Why do we have margin of errors? Maybe because of the type of sampling. Yes, that could be. What else? Do you think people always answer truthfully? No. On a survey? No, not always. Not answering truthfully, maybe not a good sample. Anything else that you can think of? Oftentimes when they're talking about polling, how satisfied is the American public with, the job that the president's doing? They'll say it's blah, blah, blah with a margin of error of, 2% or something, 2 points, up or down. All right? Okay. So, homework. Check for late or missing work. So we are done for today. I have a lot of people who are behind on the homework. And yes, Miss Didi is behind on grading. I'm hoping to get to that tonight. Also, I will be here tonight for some after school tutoring. If anybody's interested in that, I am going to look and see if I have everybody's data from the very first or second day, because we are starting our project next week. You will have all 5 days to work on that project. It will be due on Friday. Okay? Due on Friday. And you will be using our classroom data. All right? So I will be looking at that. I will be grading some of the hurricane stuff and doing homework, grading homeworks. Okay? Any questions from you? All right, please use your time wisely. Okay? When you have extra time, that's when you need to do a little bit of work. Right, Arturo? Yes. Okay.